Hey everyone, it's Chris. Welcome back to another part to our Mario Clone tutorial series. This part will cover the enemy AI, and like I said previously, this copies a lot of the logic from the player class. So a lot of what we're going to go over is not going to be very new to you, but it's going to reinforce those things that you've learned about raycasting in the player class. So to get started, let's go ahead and open up our enemy AI script. Actually, to get started, let's close that script and let's select our enemy. And as you can tell, the script isn't part of his of the game object yet, so we're going to add that as a component. So just drag that over here, okay, so that we don't forget to do that later. So our enemy AI script is already part of our enemy, so we're good there. And so let's go ahead and launch that. And just as with the player, we're going to go ahead and add some variables. And the one we know we're going to need is a gravity, because we want, if the enemy is walking off of a platform, the enemy's going to have to fall. So we're going to need a gravity to pull the player down. Or to pull the enemy down. Okay, so we're also going to need a walk speed, so that we can tell the enemy how fast it should walk. And then we're going to need a boolean to basically hold the state of the direction that our enemy is currently walking in. So we're going to make that public so that we can manipulate that in the inspector for the enemy. So right now we only have one enemy, and we're going to set its walking state to true. But if we have multiple enemies and we want them to start off walking in the right direction instead, we would set that to false. That's what we're going to use this variable for, is to control the walking and to check what direction it's currently walking in. Okay, and then we already know from the actually, you know what? Let's get rid of this walk speed, and let's do the same thing we've done for a player. And we're going to create a vector 2 and call it vector 2 and call it velocity. And we're going to set our walk speed by using our x velocity. Okay, and let's see here. We've got just as with the player, we're going to also need to know if we're grounded. So let's create a boolean for that. And initially we are not going to be grounded. And just as in the player class, we are going to create a enumeration. We're going to call this enemy state, and the enemy is going to have three states. One is walking, then falling, and dead. Okay. Now we're going to actually create our variable of our enumeration. So our enemy state enumeration is the type, and we're going to create a state, and we're going to set it equal to falling. We're going to initialize it with the falling state. So enemy state dot falling. Okay. Those are all the variables we need for now. And the first thing we're going to do with this enemy, and I'm going to talk about this in a minute, but we are going to set it to not be enabled. Okay, because in our update method, we're going to basically tell the enemy to start walking, and it's going to continue to walk forever and ever, back and forth. So we don't want the enemy to start walking in the very beginning, because if you've ever played the original Mario, you'll notice that if you stay at the very, very beginning of the level and you don't go to the right away, the enemy that you encounter, the very first one in the first level, does not start walking towards you until you're actually in its view. And that, helps you actually optimize the code. You don't want your enemies or any other obstacles for that matter that are not currently in the camera's view. They don't necessarily have to be enabled. They don't have to take up CPU time, or steal frames from other things that need to run in order to do updates, because we don't see them, so we don't care whether they do updates or not. So we're just going to disable anything that's outside completely. So then the question comes up is, how do we know if the camera, or if the object that we've disabled, how do we know when it comes into the view of the camera? Well, Unity actually has a method that makes this very, very, very simple for us. So all we have to do is call this method, and it is called onBecameVisible. Now this method is called whenever the game object that this script is attached to is visible by the Unity renderer. So that means not only in the camera's view, but also if you're in the scene view and you're looking and you can see the game object that the script is on, that's going to become visible, and then it'll be enabled. So for our purposes though, this is fine, because this will be enabled as soon as the camera comes into view of the game object, our enemy. So at that point, all we want to do is we want to change enabled to true. So we start out, when we initialize, we disable the script, and then when we come into view, we enable the script. Alright, so the next method we should probably go ahead and create is we're going to need a fall method, just like we added for the player, because like I said, our enemy is not always going to be on the ground. It's going to be on top platforms, and when it walks down, it's going to need to fall. So we don't want it to walk in the sky, so this is the method we're going to use to pull it down. So we're going to set velocity .y equal to 0. And we're going to change the state of our enemy to enemy state.falling. And we're going to change grounded to false. Okay? Because we know we're falling, so we're not grounded. And the state, of course, enemy state falling means it's falling. Alright. So what's next? Let's go ahead and at the very beginning, in our start method, let's go ahead and call the fall method, so that's how we're starting our enemy is on the ground. Okay, and let's go ahead and create update enemy position. Okay, and let's go ahead and call that from the update method. Alright. Okay, so we've got a couple of different states here. Remember when we created this enumeration, right? So we've got walking, falling, and dead. The dead state we're going to use for if the player has interacted with the enemy in a way that kills it, we're going to set its state to dead. And that's going to prevent it from doing any more position updates. So that's what we're going to check here first in the update enemy position method. We're going to check if its state is equal to dead. Because if it's equal to dead, we don't want it to do anything else at all. So in our if statement, we're going to write if state does not equal state enemy state of dead. Then we'll do our position updates. And as with the player class, we're going to create a vector3 reference position of our transform.local position and a scale. And in this case, we're not going to use scale to actually flip the enemy, because this enemy is looks the same whether it's going left or right. It makes no difference. Now we could use this for other enemies because you know, they do look different. We don't have any other ones though, so it really doesn't matter. What we're going to use this for is to help control the direction of the raycasts, because we still need to be able to raycast left or right, so we need to know the direction it's walking in. Okay, so we've got the local scale. All right. Now, we should go ahead and check if our state is falling, because if our state is falling, we want to make sure that we're pulling the enemy down to the ground. So we're going to go ahead and add that in. If state equals character state, or enemy state, dot falling. Okay. And the other state we're going to check is if state equals enemy state dot walking. Okay. Let's go ahead and fill out our falling if statement. And basically what we're doing here is the same as the player. We're going to set the y position to increment our y velocity by delta time. And then we're going to set our y velocity. We're going to decrement it, gravity times time by delta time. Okay. And that will take care of the falling state. And we don't have to worry about a jumping state here because our enemy is not going to jump. So all we need to worry about is decrementing the velocity and from its current velocity, and changing the position based on that. So the next part of this is going to be the walking. Okay, so we are actually going to So we're actually going to use our is walking left. Okay, so we're going to check if we're walking left. If the state is walking. And if we're walking left, we want to update our position x. We want to decrement it by our velocity dot x times time dot delta time. Because remember, the x velocity is what we set in the inspector to be our walk speed. Okay, and then we want to scale dot x equals -1. Because we are walking left. So our scale is going to be flipped to -1, which is also going to be the direction that we're going to pass in when we're checking our wall collisions. Okay. So if we're not walking left, then we are walking right, because we're never idle. So if we are walking right, then we're going to update our position. We're going to increment it by our x velocity times time dot delta time. And we're going to set the x scale equal to 1 instead of -1, since we're walking in a positive direction. Okay. And finally, at the end here, inside the if statement that checks to see if our enemy state is dead or does not equal dead, we set our transform the local position equal to our reference position, and set our transform dot local scale equal to our scale. All right, so enemy state dot walking. Right now we don't have any code to actually put our enemy character into this state. So we have to create that, and the best place to actually add that to is into the method that we're going to use to cast ground rays to check and see if we're on the ground. Because if our enemy is on the ground, we want the enemy to be walking. That's basically what it's supposed to be doing, is walking when it's on the ground. So let's go ahead and create that. Check ground. Oops, we don't want to return a void. We don't want a void, we actually want to return. So we will return vector 3, and check ground. We're going to pass in our current reference position to vector. Okay. All right. Now, just as before, we're going to go ahead and create our our origins. So we're going to have a left, center, and right because we're going to be casting rays down. So let's go ahead and create those vector 2, origin left, new vector 2, and that's position.x. We're going to subtract half and add back 0.2, and position y is going to minus 0.5 because the enemy is only 1 unit tall. We are subtracting half to put this origin at the bottom. All right. Then we're going to create origin middle, new vector 2, and we're going to take position.x, and I'm just going to leave it there because that's the center, and position.y minus 0.5f, vector 2, origin right, so new vector 2, position.x plus 0.5f minus 0.2f, and position.y minus 0.5f. Right. Now that we have our origins, we can create our hit objects, and we're going to do this the same way, raycast hit 2D. And we're going to create a ground left equals physics 2D dot raycast. Oops, not raycast. Raycast. And we're going to pass it origin left. And we're going to go into the down direction. And we're going to pass it velocity.y as the length times time.delta time. And we're going to pass it the floor mask, which we haven't created yet for the enemy for this script. So let's go ahead and create that up here. Layer mask, floor mask. So pass this floor mask. Close that up. Right, that's our left. Now we also need to create our middle and right. So ground middle, physics 2D, raycast, origin middle, vector 2 down, velocity y times time dot delta time, and floor mask, raycast hit 2D, ground right, physics 2D, raycast, origin right, vector 2 up down, velocity y, time dot delta time, floor mask. Alright. Now we need to check and see if any one of them doesn't equal null. So if ground left doesn't equal, or dot collider doesn't equal null, or ground middle collider doesn't equal null, or ground right dot collider doesn't equal null. Okay. So if any of them don't equal null, we now know that it is colliding with the ground. So we want to create a reference to our raycast hit object. Name it hit ray. We're going to initialize it with ground left. Okay. Then we're going to write an if statement to check each of the ground hit objects and see if they actually contain a hit object. So if ground left contains a hit object, we're going to set hit ray equal to ground left. Else, we're going to check if ground middle as a hit object. And if it does, we're going to set hit rate equal to ground middle. Else, we're going to check if ground right has a hit object. If it does, we're going to set hit rate equal to ground right. And if it doesn't, we don't belong here and we must leave and forget about this if condition altogether. To make sure that our enemy, when it's colliding with the ground, is actually seen on the ground, we're going to do the same thing that we did with the player, and we're going to set its Y position to be at the top of the ground. So we're going to do this by using our hit collider object. So hit.collider, hit ray.collider, that bounds. We're going to get its center Y position. We're going to add hit ray.collider, that bounds, that size, divided by 2 plus half of the enemy's height, and that's going to put its bottom against the top of the ground, so it's going to look like the enemy's actually on top of the ground that it collided with. Then we're going to set grounded equal to true, because we are now on the ground. We are going to reset velocity.y to 0. And finally, we're actually going to set our state to enemy state dot walking, because now that we're on the ground, we want to be walking. And then what we'll do is, if we're not colliding with anything below us, we know that we're falling. So we are going to first check to make sure that our state isn't already in a falling state. And then if we aren't in a falling state, we're going to go ahead and call the fall method, which will pull us back down to the ground. Right. So this will make sure that our enemy stays on the ground. It'll also start to set our state to the walking state. So this should actually get this whole process started, and at this point our enemy should be able to walk and collide with the ground. Once we actually check to see if we're on the ground, so we actually need to add that bit of code in here still. So we need to check if our y velocity is less than or equal to 0. Okay, if it is, then then we want to go ahead and set our position equal to the return value of check ground by passing in the position, which checks our ground collisions to see if any of our raycasts are contacting with the ground, and if they are, then we're going to get a new position, which is the position that our enemy object should be in. Okay, and then we actually just set that to our transform's local position. Okay. And that should start our enemy walking. It'll be able to walk through walls because we're not checking those collisions just yet, but this should actually work. So the enemy is going to be disabled at first, so he's not going to start walking towards us, but once we actually get him into the camera's view, all this stuff is going to start happening. So let's go ahead and save this, open up Unity, and let's go ahead and click play. And yeah, all compiler errors have to be fixed before you can enter play mode. Lovely. What's the problem? Here, hit ray.collider.bounds.size. We actually need the y value of that. We can't just pass it the vector 2. So save that. Go back to Unity. Not all code paths return a value. Okay, so what? Let's see here. What's not? Oh, you know what? We actually forgot to return our position. Okay. Save that again. Now go back to Unity. Okay, all of our errors are gone. We've got a couple of warnings, but we don't need to worry about these. Actually, we do need to worry about floor mask. We need to assign that in the enemy game object. So we also need to give our enemy a velocity. And what we'll do, let's set that to 2, and we'll go ahead and set the gravity as well. Let's set that to 60. And the floor mask. Where's our floor mask? We didn't make that a public variable, I bet. So let's go back, look at our enemy script. Yep, we did not make that a public variable. So the inspector can't see it. So now it's public. Let's go back to the inspector. Now we've got a floor mask here, and we're going to set it to default. Alright, so we've got an X velocity, we have a gravity, and that's pretty much it. So let's go ahead and click play. And I'm just going to wait here for a few seconds to make sure that our enabled, disabled thing works with our camera view. And it appears to be, unless the enemy just isn't moving like it should be. But let's go ahead and start walking towards where our enemy is. Oh, and there he is. He started walking. Okay. So you'll notice right now I can't interact with this enemy just yet. And the enemy just walked past the screen, which is not going to happen because we are going to right now implement a method that is going to make sure that our enemy cannot walk past walls. So I'm going to go ahead and end it here, and we're going to do another tutorial. Next tutorial, like I said, it's going to check the walls and make sure the enemy can't walk past them, and we may actually add in some more code to add in the interactions between the player and the enemy. So stay tuned for that, and I'll see you guys soon.